what you see outside. So outside, you might see, I don't know, a couple of browns and a green. You might then go, in your shop, you might have different lighting. So in your shop, you might be using a slightly different fluorescent tube, and now you've got quite a reddy brown here, you've got a sort of muggy greeny brown there, and a green here. You might go home and look at them under a very yellow light source, like a light bulb. Again, well, pretty similar to the shop. Or you might have cool white tubes in. And with cool white tubes in, wait a minute, what colour is this one? Brown. So we've got a complete hue shift here. And what I can do is I can take this out. So the only thing that's different is the light source. So the light source in here is different to these tubes here. And you get crazy colour shift. Okay? Now, dyes like these go in the bin. Nobody wants dyes like these because you want your clothes to match in different light sources. It's no good if you're going out and you're buying a suit and you've got, you know, perhaps it's a green suit or whatever, and it changes colour, so the suit and the trousers change colour. So what you do as specifiers is you say, I want my colour matches to hold under several different light sources. Okay? Usually, the lights in your shop, whatever those are, plus daylight outside, plus whatever you think is going to be a common light source for your home as well. So you want them to match, usually under 3 different light sources. Okay. Where we tend to see this effect, and it's a bit like magic, so it's called metamerism. And it's where we have a pair that will match under one set of conditions, but fail to match under another set. Okay? So metamerism. In our case, the thing that's changing here is the light source. So we call this illuminant metamerism. We'll talk more about that in the lectures. Where we see this effect more and more is in shops, in terms of navies and blacks. So you might have done the same at home. You might have picked up 2 socks, put them on in the dark or in under a light bulb, and they look the same. And then when you go outside, you've got a navy and a black sock on, and you can tell the difference. But that tends to be where we get most illuminant metamerism now, in the navies and the blacks. Okay. So that's for pairs of samples. So what colour is this piece of paper? White? What colour is this piece of paper?
White.
Okay. We can do this really easily. So we can take this nice white piece of paper, and we know it's white. These are different light sources. If I take an image with a camera, or if I ask a computer what colour they are, the computer will say, well, that's actually slightly yellowy. Slightly yellow, that's slightly blue. Okay, so it doesn't categorise it in the same way. But the idea that this piece of white paper stays white in different light sources, so a single thing now, that's called colour constancy. So colour stays constant to us, even though there's different light sources, because our brain does something clever. Okay. What I'd like you guys to do today for me is I want to try and have a look at your colour vision. So if you have anybody in your organisation who are going to make colour judgments, you need to be sure that they are making sensible colour judgments. Okay? If you were brought up in this country, probably by year 5, usually a bit earlier than that, you will have seen this test. Now these are called Ishihara pseudo-isochromatic colour plates. It's a mouthful, but they're the dotty number pictures. Okay? Can everybody see that? Yeah, can everybody see that? Brilliant. If you can't see the number embedded in there, then we've got some great research papers, because that is the least common colour deficiency. Blue, yellow is the least common. Now what you'll find is about 8% of the population are colour deficient. The majority of those are males. So doing these lab classes, it's the female's fault though, before you look accusingly at the guys. It's a recessive trait that's held on the X chromosome. So ladies, if you get 2 X chromosomes, it's recessive. If you get 1 good copy, you're fine. Brilliant colour vision. The guys, we get 1 X, 1 Y, we get 1 copy of colour deficiency, that's it. We're in trouble. So 8% of the population, roughly, guys, colour deficient, particularly in this direction, where they confuse the reds and the greens. It doesn't mean that they don't see colour. So what I'd like you to do when you're doing this test is have a look through a green filter for me. And what you'll see is there'll be lots of different shades of green, but you won't be able to distinguish the number from the background. Okay? So this will mimic what a colour deficient would see. We've had 3 of the boys so far being colour deficient in the labs this year. Every year I've done this, and I've been doing visual vision labs for about 12 years. There's only 1 year I can remember where we haven't had somebody who's colour deficient. So, ladies, you're usually fine. This is the most basic test. If anybody is going to do these colour judgments for you, then you'd expect them to, at a minimum, do this. If they fail this test, it means that they're likely to be deuteranose, which means they have 2 cone classes. That means that they're probably missing either the red or the green cone class. And that's why they confuse these particular shades. But there are other forms of colour deficiency, and one of them is basically it's called being an anomalous trichromat, which means that you do have 3 cone classes, but they're not in the same places. Their peak performance isn't in the same place as at colour normal. Right, so enough talking from me. You'll see on your sheet there's a little table to complete, and that's for these colour blindness tests. If we want to investigate a little bit further into where somebody's deficient, we use something called the Munsell 100 hue test. Now all these tests should be undertaken in daylight, because that's what they're designed to be. So in the 100 hue test, you have a starting colour and an end colour, and a set of chips that are supposed to be spaced to take little steps between the 2. Okay, so you start off with this colour, for instance, and you find the chip that's closest to that colour, and you find the chip that's closest to that colour, all the way across. Okay? Guys who are deficient in particular ways will make certain mistakes. Once you've finished, how do you know if you've done okay? The chips have got numbers underneath, so you'll be able to see if you've got the right order or not. But have a go at them, and have a go at working out where you are. We've got some online colour vision tests as well, so we'll do a couple of those, and we'll see how you get on there. Right, enough talking from me. Let's start some. I'll put you into groups first. So you 1, 2, 3, 4. You can go here. Is that all right, or do you want to go 4 here? Or? Yeah. Okay. 4.